NEC 110.14 current, and B addresses conductor ampacity based on temperature ratings. Subparagraph A states that for circuits rated 100 amps or less, the ampacity of conductors must be based on the 60 degrees Celsius, which is 140 degrees Fahrenheit conductor temperature rating. Subparagraph B specifies that for circuits rated over 100 amps, the ampacity of conductors should be based on the 75 degrees Celsius, which is 167 degrees Fahrenheit conductor temperature rating, unless the conductor is marked otherwise by the manufacturer. The code essentially means that for circuits rated 100 amps or less, one must adhere to the 60 degrees Celsius ampacity ratings for conductors, regardless of whether the conductors themselves are rated for 75 degrees Celsius. This stipulation arises from the fact that lugs are generally rated for 60 degrees Celsius, thereby restricting the conductor ampacity from surpassing the lug rating. Conversely, for circuits rated exceeding 100 amps, one can leverage the 75 degrees Celsius ampacity ratings for conductors, provided that the conductor is designated for that temperature rating. This allowance stems from the typical 75 degrees Celsius rating of lugs in such circuits, enabling the conductor ampacity to exceed the lug rating. Considering a scenario involving number 6 THW wire deployed in a circuit rated for 50 amps, number 6 THW wire exhibits a 60 degrees Celsius ampacity of 55 amps and a 75 degrees Celsius ampacity of 65 amps. Given that the circuit is rated for 50 amps, adherence to the 60 degrees Celsius ampacity of 55 amps is mandatory. This requirement is imposed due to the conventional 60 degrees Celsius rating of lugs, which restricts the conductor ampacity from exceeding the lug rating. In essence, for circuits rated 100 amps or less, compliance with the 60 degrees Celsius ampacity ratings for conductors is imperative, even if the conductors boast a 75 degrees Celsius rating. Conversely, for circuits rated above 100 amps, the 75 degrees Celsius ampacity ratings for conductors can be employed, contingent upon the conductor being marked with that specific temperature rating. Let's delve further into the intricacies of conductor ampacity and temperature ratings as delineated in the National Electrical Code. Understanding these nuances is crucial for ensuring safe and compliant electrical installations. The NEC provides detailed tables such as Table 310.16, which outline the allowable ampacities of insulated conductors rated up to and including 2000 volts. These ampacities are based on specific conditions, including the conductor's insulation type, its size, and the ambient temperature. However, NEC Section 110.14c introduces additional considerations related to the termination temperature limitations which can further restrict the allowable ampacity. Firstly, it's essential to differentiate between the conductor's insulation rating and the termination rating. The conductor's insulation rating, such as 75 degrees Celsius or 90 degrees Celsius, indicates the maximum temperature the conductor's insulation can withstand without degrading. The termination rating, on the other hand, refers to the maximum temperature that the terminals or lugs at the circuit's termination points are designed to handle. NEC 110.14 current specifically addresses these termination temperature limitations. It mandates that the ampacity of a conductor must be selected such that it does not exceed the lowest temperature rating of any connected termination conductor or device. This means that even if a conductor has a high temperature rating, its ampacity must be chosen based on the lowest rated component in the circuit. For circuits rated 100 amps or less, the NEC typically requires the use of the 60 degrees Celsius ampacity column in Table 310.16. This is because many smaller circuit breakers, switches, and other devices are only rated for 60 degrees Celsius terminations. Even if the conductor itself is rated for 75 degrees Celsius or 90 degrees Celsius, the 60 degrees Celsius ampacity must be used. For circuits rated over 100 amps, the NEC generally permits the use of the 75 degrees Celsius ampacity column in Table 310.16, provided that all terminations are rated for 75 degrees Celsius or higher. However, it's crucial to verify the temperature rating of all terminations before using the 75 degrees Celsius ampacity. If any termination is only rated for 60 degrees Celsius, the 60 degrees Celsius ampacity must be used, regardless of the circuit's ampacity rating. There are exceptions to these general rules. For example, some equipment is specifically listed and marked for use with 75 degrees Celsius conductors, even in circuits rated 100 amps or less. In these cases, the 75 degrees Celsius ampacity can be used, provided that the equipment is installed according to its listing and labeling. It's also important to consider the ambient temperature when selecting conductor ampacity. Table 310.16 is based on an ambient temperature of 30 degrees Celsius, which is 86 degrees Fahrenheit. If the ambient temperature is higher or lower than this value, correction factors must be applied to the ampacity to account for the temperature difference. These correction factors are provided in NEC Table 310.15b2. Furthermore, if multiple conductors are bundled together in a raceway or cable, directing factors must be applied to the ampacity to account for the increased heat generated by the conductors. These directing factors are provided in NEC Table 310.15b3. Let's illustrate these concepts with a few examples. Firstly, consider a 20 amp circuit wired with number 12 THHN conductors. THHN is rated for 90 degrees Celsius. However, the circuit breaker and receptacle are only rated for 60 degrees Celsius terminations. Therefore, according to NEC 110.14, the 60 degrees Celsius ampacity of number 12 THHN must be used, which is 20 amps. Secondly, consider 150 amp feeder circuit wired with number 1/0 XHHW conductors. XHHW is rated for 90 degrees Celsius. The circuit breaker and panel lugs are rated for 75 degrees Celsius. Therefore, the 75 degrees Celsius ampacity of number 1/0 XHHW can be used, which is 150 amps. Thirdly, consider a 30 amp circuit wired with number 10 THHN conductors in an ambient temperature of 40 degrees Celsius. The circuit breaker and receptacle are rated for 60 degrees Celsius terminations. The 60 degrees Celsius ampacity of number 10 THHN is 30 amps. However, a temperature correction factor must be applied to account for the higher ambient temperature. According to Table 310.15b2, the correction factor for THHN in an ambient temperature of 40 degrees Celsius is 0.88. Therefore, the corrected ampacity is 30 amps multiplied by 0.88, which equals 26.4 amps. The circuit breaker must be reduced in size to 25 amps or less to comply with the NEC. Fourthly, consider a 20 amp circuit wired with number 12 THHN conductors, with 6 current carrying conductors bundled together in a raceway. The circuit breaker and receptacle are rated for 60 degrees Celsius terminations. The 60 degrees Celsius ampacity of number 12 THHN is 20 amps. However, a directing factor must be applied to account for the bundled conductors. According to Table 310.15b3, the directing factor for 4 to 6 current carrying conductors is 0.80. Therefore, the derated ampacity is 20 amps multiplied by 0.80, which equals 16 amps. The circuit breaker must be reduced in size to 15 amps or less to comply with the NEC. In summary, NEC 110.14 code is a crucial section of the code that addresses termination temperature limitations and their impact on conductor ampacity. It mandates that the ampacity of a conductor must be selected such that it does not exceed the lowest temperature rating of any connected termination conductor or device. For circuits rated 100 amps or less, the 60 degrees Celsius ampacity is generally required, while for circuits rated over 100 amps, the 75 degrees Celsius ampacity is typically permitted, provided that all terminations are rated accordingly. Temperature correction and directing factors must also be considered to ensure that the conductor ampacity is appropriate for the specific installation conditions. Adhering to these requirements is essential for ensuring safe and compliant electrical installations. Remember to always consult the latest edition of the NEC and seek guidance from a qualified electrician when working with electrical systems. Understanding conductor ampacity and temperature ratings is vital for electrical safety. Ignoring these requirements can lead to overheating, insulation damage, and potentially dangerous situations. In addition to the points discussed earlier, it's also important to consider the type of equipment being supplied by the circuit. Some equipment, such as motors and air conditioners, may have specific requirements for conductor ampacity and termination temperature ratings. These requirements are typically specified in the equipment's listing and labeling. For example, a motor may require the use of conductors with a high temperature rating to account for the heat generated by the motor. Similarly, an air conditioner may require the use of specific types of terminals or lugs to ensure a reliable connection. It's also important to be aware of the potential for voltage drop in long circuits. Voltage drop occurs when the voltage at the load is lower than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. To minimize voltage drop, it's important to select conductors with an appropriate size for the length of the circuit and the load current. The NEC provides guidelines for calculating voltage drop and selecting conductor sizes. When selecting conductors, it's also important to consider the environment in which the conductors will be installed. Conductors that are exposed to moisture, chemicals, or extreme temperatures may require special insulation or protection. The NEC provides requirements for the installation of conductors in various environments. Firstly, dry locations or areas not normally subject to dampness or wetness. A location classified as normally dry may be temporarily subject to dampness or wetness, as in the case of a building under construction or a partially protected location under a canopy, marquee, or similar structure. Secondly, damp locations are locations protected from weather and not subject to saturation with water or other liquids but subject to moderate degrees of moisture. Examples of such locations are partially protected locations under canopies, marquees, roofed open porches, unlike locations and interior locations subject to moderate degrees of moisture such as some basements, some cold storage warehouses, and the like. Thirdly, wet locations are installations underground or in concrete slabs or masonry in direct contact with the earth, locations subject to saturation with water or other liquids such as vehicle washing areas, and unprotected locations exposed to weather. It is also important to consider the type of wiring method used in the installation. The NEC recognizes various wiring methods, each with its own set of requirements. Some common wiring methods include rigid metal conduit, electrical metallic tubing, flexible metal conduit, non-metallic conduit, and cable assemblies. The choice of wiring method depends on factors such as the environment, the type of building, and the desired level of protection. When installing conductors, it's important to follow the manufacturer's instructions and the NEC requirements. Conductors should be properly supported and secured to prevent damage. Connections should be made using approved methods and materials. The installation of conductors should be protected from abrasion and damage. It's also important to ensure that conductors are properly identified and labeled. This helps to prevent confusion and makes it easier to troubleshoot problems in the future. In addition to the technical aspects of conductor ampacity and temperature ratings, it's also important to consider the economic factors. Selecting conductors that are too small can save money upfront, but it can also lead to increased energy costs, reduced equipment life, and potential safety hazards. Selecting conductors that are too large can increase the initial cost of the installation, but it can also improve energy efficiency, reduce voltage drop, and extend equipment life. The optimal conductor size is a balance between cost and performance. Finally, it's important to stay up to date on the latest changes to the NEC. The NEC is revised every 3 years, and it's important to be aware of any changes that may affect your work. Continuing education courses and professional organizations can help you stay informed about the latest developments in electrical safety. In conclusion, understanding NEC 110.14 code and other related requirements is essential for ensuring safe and compliant electrical installations. By considering the conductor's insulation rating, the termination temperature rating, the ambient temperature, the number of bundled conductors, the type of equipment being supplied, the potential for voltage drop, the environment, the wiring method, and the economic factors, you can select conductors that are appropriate for the specific application. Always consult the latest edition of the NEC and seek guidance from a qualified electrician when working with electrical systems.